Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, maximum score after applying operations on a tree. The problem is almost similar to the last week's weekly contest problem. We have already discussed that problem in this video, maximum points after collecting coins from all the nodes. If you have watched this video, I would strongly encourage you to pause and try to solve this problem by yourself. If you haven't watched this video, I would say after watching this particular video you can solve this problem by yourself as a follow-up. With that, let's get started. The problem states that you are given an unrated tree with n nodes rooted at node 0. You are given the edges of the tree. Now each node has some value associated with it. You will start with a score of 0, and in one operation you can pick any node, add values I to your score, and reset the value to 0. So basically in any one operation you are taking the value of the node into your score, resetting the value of the node itself. A tree is considered healthy if sum of values on the path from root to leaf node is different than 0. Now your task is to maximize the score by keeping the tree healthy. So let's take an example. Let's say this is the tree and these are the values. Basically the value of node 0 is 5, value of node 1 is 2, value of node 2 is 5, value of node 3 is 2, and so on and so forth. Now you need to take out some score. Like in one operation you can pick any node, reset its value, and add the value to your score. So one possible option could be you take 1, add this value to your score. So you add 2 to your score. So now your score is 0 plus 2, 2. You take 2, add the value 5 to your score, and reset this value. So this already is become 0, this has become 0, and now your score is 7. Similarly, you take this 3 node and also reset its value. So now your score is 9, the value is 5, 0, 0, 0. Similarly, for other two, you reset it and add it to your score. So now your score becomes 11, and the values of the node are 0 has a value 5, all other has a value 0. Now is the tree healthy? The answer is yes. If you see, this is one path from root to leaf. What is the sum of all the values? 0 plus 0 plus 0 plus 5, which is 5, which is different than 0. So this condition, this root to leaf path is satisfied. This root to leaf path is also satisfied because 5 will be there. Again, this root to leaf path will also be satisfied because 5 will be there. So the entire tree is still healthy, and 11 is the maximum score you can collect by not making the tree not healthy. You can try out any other possible combination. You will not be able to keep the tree healthy and get a score of greater than 11, and hence the answer here is 11. So hope the problem statement is clear. Now how to solve this? As always, let's start with the smallest or the simplest form of a tree, which is an array. So let's say the tree is looking like this, so it is nothing but an array. So let's say we have 10 nodes in the tree, each node has these values. Now we want to solve the same problem. The problem is we need to collect as many score as possible without making the tree non-healthy. In other words, we want to keep the sum of all the values in this entire path greater than 0 and collect as much score as possible. So what you will do? Let's look at the first node. What are the choices for the first node? Either you will take it into your score or you will not take into your score. Basically, either you will reset this to 0 and add 5 to your score, or you will keep this 5 as it is. So two choices, right? So let's say you keep this 5 as it is. So now what you have remained? You have been remained with these all nodes, and you can now take every one of them. Why? Because you already have skipped one. So this is non-zero value, right? This is 5 value. Everything else, even if they are 0, the total sum will still remain greater than 0, right? So this is the first criteria wherein you skipped 5. What is the second criteria? Second criteria is you take 5. If you take 5, the score is now incremented by 5, right? And now what you have been remained with is these all nodes. What you want the tree to be healthy. This is already 0, so this piece is left. So isn't like you can just simply ignore this and then say, okay, this is my reduced tree and I need to solve for this tree itself. In other words, this is my reduced nodes and I have to just find out what is the maximum score I can collect without making the tree non-healthy. Notice that you have taken this already, and because you have taken this already, this will not affect any of the decision afterwards, because to keep the tree healthy you still need to make sure that the every path from root to leaf is still have a value greater than 0, right? So isn't this problem exactly similar to the original problem? Original problem was we have an array, we need to find out what is the maximum score we can collect by making sure the sum is still greater than 0, right? Now we are saying we take 5 and now we have an array which is a smaller array, and we need to make sure what is the maximum number of score you can collect without making or having the entire sum still as greater than 0, right? So hope you can see the recursion here. Let's look at the formal recursive structure. So I just sorted the array so that it is the tree is bit clear. So we start with f0 comma false. Basically we have two cases, right? Either we will start with index I. We have two cases. Either we have skipped something already before, right? Or we haven't skipped anything before. Only two possibilities. Why we are not, like, we don't care what we have skipped, because everything in our tree is already greater than 0. So even if we have skipped just one node, that is completely sufficient to make sure that the remaining sum is greater than 0. So it doesn't matter what we have skipped, we just need to make sure that we have skipped at least one node. That's the only criteria we need to satisfy. So we'll start with f of 0 comma false. In other words, we are saying starting from index 0, tell me what is the maximum score I can collect, given that I haven't skipped anything before, right? So we have to skip something starting from index 0. That's what it means. Now from here, as we have discussed, we have two choices. Either we will take the index 0 or we will not take the index 0. So if we skip the index 0, it means we have already skipped one index before, no matter which index we have skipped, and now we have to make sure what is the maximum score I can collect starting from index 1, right? So one of the way you can see here is once you have skipped something, you can keep on taking all the values till the leaf, because once you have skipped something, you are sure that remaining path starting from that node, the sum would always be greater than 0, right? So from f of 0 comma false, if you have skipped, then you will be landing to f of 1 comma true. From f of 1 comma true, you will land to 2 comma true. Notice that in this stage what you have done, you have added 6 to your score, right? Similarly, from f of 2 comma true, you will say starting from index 1, give me what is the maximum score I can collect. Starting from index 2, give me the maximum score I can collect, given that I have skipped one index before. It means I have the ability to skip everything now. So I will just say just take current element, right? um, just take the current element because we have already skipped, so it doesn't matter whether we skip this or not. So let's just take current element value, which is 8, and move forward. In other words, say what is the maximum score you can collect starting from index 3, given we have skipped something already. So again, from here you will take element 9, a value 9, and now you are at 4 comma true, which means starting from index 4, give me what is the maximum score I can collect, given that I have skipped one thing already before. So because you have already skipped one thing before, you are sure that whatever configuration you have done is sufficient to make sure the sum is greater than 0. So you will simply return 0 from here, right? So the value of f of 3 comma true will simply be 9. Similarly, the value of f of 2 comma true would simply be 9 plus 8, 17. Value of f of 1 comma true would be 17 plus 6, 23. And value of f of 0 comma 4 is, one of the value is 23. Like 23 is achievable. Basically, you can get a score of 23 by still keeping the tree healthy. But there are other possible choices as well. So before we finalize the value, we have to explore the other choice as well. It may happen that the other choice can give us larger value. So what we have said is, now we will take the current element. In other words, we added a score of 5, and now we are saying, starting from index 1, give me what is the maximum score I can collect, given that I have not skipped anything before, because I haven't skipped index 0. Now from here as well, there are two choices: either you will skip or you will not skip. If you skip, again you have skipped something before, right? So this will become true. You will say, starting from index 2, give me the maximum score that I can collect, given that I have skipped something before already. And for that we already know the value, which is 17. So the value of f of 2 comma true is 17. This will return to here, and the value of f of 1 comma false, one of the value of f of 1 comma false is 17. Other value is, you will say, okay, let me take index 1 as well, and because I have taken index 1, I will say I have not skipped anything. Basically, whatever was skipped previously is something skipped now as well. I have not skipped anything extra. So we need to figure out f of 2 comma false. We'll figure out f of 2 comma false, and finally we will, so let's just figure out this. So f of 3 comma true is actually 9. So we know the value of this, which is 9. F of 3 comma false, what the value would be? The value would simply be, either we will skip this or we will take this. So if we skip this, we will be at here. It means we have already skipped something. It means whatever configuration we have is a valid configuration. So this will simply return 0. So the value of f of 3 comma false is 0. From one side is 0. Otherwise, the other option is you take this as well. So in other words, you take this 9 as well. If you take this 9, you will be ending up with f of 4 comma false. It means, given starting from index 4, I have not skipped anything. Give me maximum score that I can collect by still keeping the tree healthy. But because you have reached 4 with false, it means you have taken everything till now. In other words, you have made everything to 0. So the tree is no longer healthy. So to compensate that, you will simply return, basically this is not a valid scenario at all, so you will simply return minus infinity, let's say, and this will be 0, max of 0 comma minus infinity, which will be 0. So value of f of 3 comma false is 0. Now what will be the value of f 2 comma false? Again, this one you got here by saying that you will take 8, that's why it was false, right? So the value would be maximum of 9 comma 8 plus 0, which is 9. So the value of f of 2 comma false is 9. Value of f of 1 comma false is 9 plus 6, 15, either this or 17. So what is maximum? Maximum is 17, so value here would be 17. And finally the value of f 0 comma false would be 23. Maximum of 23 comma 17 plus 5 22, 23 is maximum, so the value here would be 23. So basically you can collect a score of 23 without making the tree non-healthy. So how would the pseudocode look like? The pseudocode would be exactly similar to what we just discussed. Everything has just two parts to it. Either they will skip the value at, or skip taking the value at the current index, or they will take the value at the current index and say that I have not skipped anything extra, so whatever has been skipped previously is something which is skipped now as well. Now notice that you can optimize this a little bit by saying that if it is already true, if has skipped is already true, so you don't need to do this at all. So that is simple automation you can make, but it will not change anything here. So you have still have two choices: either you will take this or you will not take this, right? Now as we have already seen that some state occur again and again, so you might have to calculate the same state again and again. So to skip that, you can simply save the value of a particular state, and in the beginning, before calculating anything, you will just check whether you have actually calculated the value or not. If you have calculated the value, you will simply return this without moving anything further. If you haven't calculated the value, you will run this algorithm and calculate the value as well. So hope this entire solution makes sense. Now what is the time complexity of this entire solution? Time complexity is simply number of states multiplied by what you are doing inside each of these state. So what is the number of states? Distinct value of index is n, number of distinct value of skipped is 2, either true or false. So number of distinct state is 2n, right? What we are doing inside each of these state, we are simply doing some mathematical operation. We are simply calling a function, we are doing some addition and then a maximum operator. So we are doing order 1 operations inside each of these. So overall complexity of this entire algorithm is order n, which is sufficient to pass the given time constraint. Now this entire thing was on a single array, but you can use this entire thing and on the tree as well. So let's just take this final example. So we have this tree. Now we have to answer the same question: what is the maximum score I can collect without making the tree non-healthy? So again, you will start from the root, right? Either you will take this or you will not take this. If you take this, you have to now say what is the maximum score I can collect given I have not skipped anything before. Similarly, if you will say what is the maximum score you can collect given I haven't skipped anything before. What is the maximum score I can collect given I haven't skipped anything before? Let's say you get x1 from here, you get x2 from here, you get x3 from here. So without taking 2, the maximum score you can collect is x1 plus x2 plus x3, right? In the same fashion, the second condition would be you have taken 2. It means your score is already incremented by 2, and now you are saying what is the maximum score I can collect from this tree given I have skipped something already. Maximum score I can collect given I have not skipped something already. Similarly, I have not skipped something already. What is the maximum score I can collect given I have not skipped something already? So this is already similar to what we have just seen. So instead of a node, instead of an index, here we will have a node of the tree, which will just say what is the maximum score I can collect given whether we have skipped something or not already, starting from this particular node, right? So everything else will be exactly straightforward. The pseudocode would be also straightforward. We have just two choices: either we will take this or we will not take the current route. So if you take the current route, it means you have to ask the question that what is the maximum score you can collect given that you have not skipped anything extra. So you have taken the current root. Now you are saying what is the maximum score you can collect from this child, given that you have not skipped anything extra. So whatever was skipped previously is something which is skipped today as well. I have not skipped anything extra. In the same fashion, the second condition could be, you will, sorry, this would be 0, right, without node. So you will say I have not taken the current root, so now I will say what is the maximum score I can collect from the given children, from all the children, given that I have already skipped something before. So we'll simply sum them all up, right? So we'll get what is the maximum score I can collect if I skip the current node, if I don't skip the current node. So the value finally would be max of with node and without node. Now the base case will also change. Previously the base case was if we are out of the indexes, we will simply check whether we have skipped something or not. If we have already skipped something, it means we are good, the sum is greater than 0. If we haven't skipped something, it means the current configuration is not valid. So that's where what we have said is, if the current node is a root, is a leaf, then we'll check have we skipped something till now. If we have skipped something already, I don't need to skip this, right? I can simply take this value. So that's what we have done. If we have already skipped something, I don't need to skip the current node. I can simply take the value of the current node, right? But if we haven't skipped anything, then we have to skip the current node. Otherwise, the tree will not remain healthy. So that's where if we haven't skipped anything, we will skip the current node or the leaf node, and we'll say the maximum score that you can collect starting from that leaf node is 0, right? So this is again the memorization piece, because that is required to ensure that you are not computing same state again and again, and keeping the time complexity under polynomial instead of exponential. So hope this solution makes sense. What is the time complexity? Time complexity is number of states multiplied by what you are doing inside each of the state. Number of states is again number of nodes, maximum number of distinct value of node is n, and has skipped can take two values, true or false. So number of state is still 2n. Now what you are doing inside each of the states, we are iterating over all the children twice. So if you think about it naively, number of children can be order n, right? So the tree can be something like this. So if you think about it naively, the number of children is n itself. So you will say the given algorithm is order n square complexity. But this is not true, because if you do amortization, this is not order n square, this will come to order n itself. So let's look at the time complexity analysis as well. So if you think, these are the functions that you will be computing. So you will be computing f of 1 comma true, f of 1 2 comma true, f of 3 comma true, all the way up to f of n comma true. Or you will be computing f of 1 comma false, 2 comma false, all the way up to n comma false. Now what you are doing in this function, you are iterating over all the children of 1, right? What you're doing here, you are iterating over all the children of 2. What you're doing here, iterating over all the children of 3, and so on and so forth, all the way up to all the children of n. So in a way, you are iterating over children of every node exactly once. So this complete summation will be iterating over 2n nodes only, because each edge connects to node. So this node will be a children of this node, and depending on how you create a graph, you might visit this node as well and skip this node, given and by saying that this is already a parent. So depends on the implementation, but at max you will be visiting 2n number of node across all of these, and in the same fashion you will be visiting 2n number of nodes across all of these as well. So overall your complexity is 2n plus 2n, which is 4n, or order n itself. So amortized complexity is still order n, which will pass the given time constraint. So if you have watched till this point, I would strongly encourage you to pause and try to code this entire thing by yourself. There's just one small thing which is not there in this pseudo code, which you have to figure out. If you face difficulty in coding this yourself, I would encourage you to understand why you are facing this difficulty. Watch that section and make sure that you submit the code. Next, we're looking at the code. The code is exactly what we have discussed. We just have this graph and the value of every node. So I just initialize the value with values. I have initialized the graph with the given edges. Now once we have this, I just call maxsum of 0 0 minus 1. Notice it has 3 parameters, whereas what we have discussed has 2 parameters only. What are the parameters? Parameters are node, has skipped, and parent. We haven't had parent here, right? So some of you might think that okay, if we have parent as well, the number of states would become n square into 2, which is not really the case, because given a node, because you are given a rooted tree, every node's parent is already fixed. So from this node itself, you can figure out what the value of the parent is. So you don't need to take this into this function. Instead, you can just calculate parent inside this function as well, right? You can say parent equals to some p of node, where p of node you can compute beforehand, right? But to just simplify, or to just avoid like doing two recursion, or for simplifying the implementation, I have not computed this parent array beforehand, and I am just taking the parent inside this function as well. Notice, because it is derivable from the current state itself, we don't need to take this into our DP states or the number of unique states, and the complexity will still remain order n. So now this maxsum, what we have done, we simply check whether it is a leaf. If it is leaf, we will just understand whether we have already skipped something or not. If we haven't skipped something, this is the right time to skip the leaf, because otherwise the tree will not remain healthy. So if we have skipped something, we can take the value, current value. If we haven't skipped anything, we have to skip the current leaf node, and the remaining score that we can retain is 0. Now after that, we'll check if this is something we have already computed. If we have computed, we'll return that. If we have not computed this, we have two choices: with node, without node. If we take this node, we will iterate over all the children, and for all the children we'll ask what is the maximum score you can take, but maximum score I can get from you, given that I have not skipped anything extra. Whatever was skipped is skipped already, but I have not skipped anything extra from my side. In the same fashion, without node, you will say I have skipped something. I have skipped the current node, so I have skipped for sure at least one node. Now give me the maximum sum that is possible starting from you, given that there is one node which is already skipped. Finally, you will just take the maximum of with node and without node. That will be your value of current node with this particular skip status. So maximum of 0, 0 will give you the answer. In other words, you will say if we start from 0 and if we haven't skipped anything yet, what is the maximum score I can get, which is what the problem asked for. So hope you understand the entire thing. If you have any doubts in any of the fees, feel free to follow up in the comment section below. I would be happy to answer. As discussed in the beginning of the video, I would now encourage you to go and solve this problem by yourself, which is maximum point after collecting coins from all the nodes. You can actually apply exact same trick. You can start from a simple array and solve that problem on the array. Once you have solved the problem on the array, you can move the tree and just modify the recursion to work on the tree. So hope you understand everything. If you have doubts in any of the problem, either this one or the current problem itself, feel free to follow up. If you like the video, give it a thumbs up and do subscribe if you haven't already, and I will see you in the next one. Thank you.